Have you ever wondered what everything is really made of? I mean, literally everything. The chair you're sitting on, the phone in your hand, even the air you're breathing? Well, today, we're going to dive deep into the fundamental building blocks of our entire world. Let's get right into it. So let's kick things off with something super familiar, a simple glass of water. But let's really think about it. If you could zoom in, and I mean way, way in, further than any microscope could ever take you, what would you actually see in there?
You know, deep down, at the very core of it all, you would find this, the atom. Think of it like the ultimate Lego brick. It's the basic, fundamental piece that builds every single thing in the universe. Everything starts right here.
Now, when you think atom, you've probably seen this kind of picture before, right? A little nucleus in the middle with electrons buzzing all around it. And yeah, that's totally accurate. It's this incredibly complex, beautiful little system. But to really get how these things build the world, it actually helps to simplify this picture, just for a minute.
So let's just strip away all that internal complexity for a moment. For our purposes, let's just imagine an atom is a simple sphere, kind of like a tiny little ball. We're not ignoring the details, we're just zeroing in on the most important thing for our story, its ability to connect with other little spheres.
Because here's the thing, these little atomic spheres, they hardly ever just float around by themselves. They're actually constantly looking to link up with each other. So the big question is, what happens when they do?
When they link up, boom, they form a molecule. And we're not talking about just bumping into each other. This is a real, powerful connection, a chemical bond. This is the next level of building reality. We've gone from individual little bricks to these small, tightly connected structures.
And this right here, this is basically the blueprint for everything. It's a surprisingly simple three-step process. You start with the basic unit, the atom. You link atoms together to create molecules. And then, when you get a whole bunch of molecules together, you get matter. The actual physical stuff you can see and touch. All right, so let's take that blueprint and apply it to our glass of water. We're going to see how this works in the real world by building a water molecule from the ground up, atom by atom. Now, to build anything, you need a list of parts, right? Well, in chemistry, nature gives us a palette of about 120 different types of atoms to play with. Each one is a unique element, a different kind of sphere with its own special properties. But out of all those options, the recipe for water is incredibly specific. You can't mess with it. All you need are two ingredients, hydrogen and oxygen. And the amounts are absolutely crucial. Exactly 2 atoms of hydrogen and just one, atom of oxygen. And let's be super clear here, these are two totally different things. A hydrogen atom isn't an oxygen atom. They're unique building blocks that act in completely different ways. They're different spheres from our set.
So we just follow the recipe, we take our 1 oxygen atom and we snap on 2 hydrogen atoms, and in that moment, we create something brand new. Something with properties that neither hydrogen nor oxygen had on their own. We've made a water molecule, H2O.
This exact arrangement is what makes water, well, water. It's such a simple little structure, but it's the key to everything. That specific shape it forms is the reason ice floats, it's why bugs can walk on water, it's why it's so good at dissolving things. The whole personality of water comes from this simple 3-atom team.
Okay, so we've built one single solitary water molecule. Big deal, right? It's still completely invisible. So how do we get from this one tiny thing to the glass of water we can actually hold? Well, now we have to scale things up, way up.
And this is where things get truly mind-boggling. In just a single drop of water, there are more of these H2O molecules than there are grains of sand on every beach on the entire planet. We're talking trillions and trillions of them, all packed together. It's just an unbelievable number.
So here's that whole journey laid out. We started with those tiny, invisible atoms, our basic building blocks. We snapped them together to make a specific structure, the molecule. And then we gathered a truly astronomical number of those molecules together to finally get a substance we can actually see and interact with.
Which brings us right back to where we started. What's inside that glass of water? It's a massive, swirling community of H2O molecules, and it's how they all hang out and interact with each other that creates all the properties we think of as water. The wetness, the coolness, the way it flows. It's the group that makes it real.
So think about this. Water is just 2 hydrogens and 1 oxygen. So what happens when you use different atoms, or even the same atoms, but arranged in a different shape? Could it be that this simple act of arranging these tiny spheres is the secret to creating everything, From diamonds to DNA? That's really the magic of chemistry, isn't it? Something to think about.